Hi, this is Nirmala Rednam. In this video, we are going to do the exercise 3.3 from NCERT textbook class 8. In the earlier video, we have looked at a parallelogram. What is the definition of a parallelogram? It is a quadrilateral uh, which has two pairs of parallel lines, right? And we looked at a few properties of a parallelogram. That is, the opposite sides of a parallelogram are equal in length, the opposite angles are equal in length, and the adjacent angles are supplementary. Also, we have looked at another property regarding the diagonals, that is, the diagonals bisect each other. Okay, they need not be equal, but they bisect each other. Okay, so these are the four properties that we looked at in the last video. Now let's start the exercise. So here what I have done is I have separated the questions so that we can do the sums here directly. So let's look at the first question. Given a parallelogram ABCD, complete each statement along with the definition or property that you're using to write the statement. Okay. So if you look at the first one here, they're saying AD is equal to dash. So if you look at this side, we know that in a parallelogram, opposite sides are of equal length. Therefore, we are going to write AD is equal to BC. Okay. So now here, what is the property that you are using? The property you are using is that opposite sides in a parallelogram are of equal length. Okay. Next I have angle DCB. So what is this angle DCB? DCB. This is the angle they are referring to. Now they're saying this angle is equal to which angle? Okay. We know that in a parallelogram, the opposite angles are equal in measure. So opposite to DCB, I have DAB. Therefore, I'm going to write DCB is equal to angle DAB. So what is the property that I'm using? Opposite angles in a parallelogram are of equal measure, right? Next, the third one, OC. Now what is this OC? It is a part of the diagonal AC. Now, and what is this point O? This is the point of intersection of the two diagonals. We know that the diagonals in a parallelogram bisect each other. So, this OC is going to be equal to OA. Okay. So, what is the property we are using here? The diagonals bisect each other. The fourth property that we looked at in a parallelogram, right? Okay. Next one is, they're saying measure of DAB plus CDA. Now here what is DAB? This angle is DAB. And what is CDA? CDA is this angle. Okay. Now what are these two angles? They are adjacent angles of a parallelogram, right? And we know that adjacent angles in a parallelogram are supplementary, right? Supplementary means the sum is equal to 180 degrees. Therefore, here I am going to conclude that this is 180 degrees. What is the reason? Because adjacent angles in a parallelogram are supplementary. Okay. So that is my reason. Supplementary. So that's about the first question. Okay. So we are done with the first question. We have used all the four properties that we learned. We have used them in this particular question. Right. Next, going to the second question. Consider the following parallelograms. Okay, they have given a few parallelograms and this is the first one. Find the values of x, y, z here. Okay, and we know that, in a parallelogram we have two properties regarding angles. Opposite angles are equal in measure adjacent angles are supplementary. So first if I look at x, okay, I know that x and this angle 100 degrees, these two, angle C and angle B are adjacent angles, correct? Now these two are adjacent angles and therefore the sum is equal to 180 degrees. So I'm going to write angle B plus angle C is equal to 180 degrees, right? Implies angle C is equal to 180 minus 100, which is equal to 80 degrees. So what is the value of x we got? 80 degrees, okay? And then coming to y. Y is very simple because y is the opposite angle to B. B and D are opposite angles and opposite angles are equal in measure. Therefore, y has to be 100 degrees. And now z is again equal to x, which is 80 degrees. Therefore, z is also 80 degrees. Okay. So, I have the values of x, y and z. Simple, right? Next, let's look at the second figure that they have given. Okay. Now, here I have x and y as of two angles of the parallelogram, in fact opposite angles, and z is the exterior angle of this particular vertex. Okay, so here if I name this parallelogram A, B, C and D, okay, I know that angle B is equal to angle D. Why? Because they are opposite angles of a parallelogram. Therefore, when I say angle B, it is clear that I am talking about the interior angle when I am referring to parallelogram. In parallelogram ABCD, if I mention this, I don't have to worry about naming it as ABC. Okay, simply when I say angle B, it means we are talking about this angle. So this is 50 degrees. Now, this angle and Z are a linear pair. Okay. Now Z and 50 degrees, these two together form a linear pair. That means the sum has to be equal to 180 degrees, right? Therefore, I have Z plus 50 is equal to 180 degrees, implies Z is equal to 180 minus 50, which is 130 degrees. Okay. So now I have the value of Z. What about X and Y? Angle A and angle D are supplementary, or you can say angle B also are supplementary because they are adjacent angles. Therefore, if I have angle D as 50, then angle A has to be 180 minus 50. Okay. Therefore, angle A is equal to 130 degrees. There's another way of looking at it, that if you look at these two, these are a pair of parallel lines. In a parallelogram, opposite sides are parallel and X and Z form corresponding angles. X and Z are corresponding, and you know that corresponding angles are equal in length when you have a pair of parallel lines, right? So the corresponding angles are equal in length. Therefore, once I found out Z as 130, immediately I can conclude that X is also 130. Now Y is also 130 because X and Y are opposite angles of a parallelogram, right? So I got all the three X, Y and Z as 130 degrees, right? Next, coming to the third figure that they have given. So here, this is a parallelogram. They have mentioned in the question that all the given figures are parallelograms, right? So this is a parallelogram, and because the orientation is different, let me just put these symbols so that we don't forget the fact that it's a parallelogram, right? Now here, they're saying that in this particular case, the diagonals are intersecting at right angles. Clearly, they mentioned this symbol here means 90 degrees. Okay. So, what does that make x? X is vertically opposite to 90, therefore, x is also 90 degrees, right? Now, if I have to name this. Let me name it as A, B, C, D. And the point of intersection of diagonals as O. Okay. So, now, if I look at triangle BOC. Okay, sum of the angles in a triangle is 180 degrees, and I already know two angles, so I'm going to write y plus 90 plus 30 is equal to 180 degrees. Therefore, y is equal to 180 minus 120, which is 60 degrees. So I got the value of y as 60 degrees. Right? Now, if y is 60, what can you say about z? Now, if you look at this, AD is parallel to BC. Consider CA as the transversal. That makes y and z alternate interior angles. So, z is equal to y, which is equal to 60 degrees. I'm going to repeat it. If you consider AD and BC, you know that these two are parallel. Okay, because it's a parallelogram, it is given to us. And now consider AC as the transversal. You can extend if that makes you comfortable. Extend it. AC is the transversal. And between two parallel lines, we know that alternate interior angles are equal in measure. That means y is equal to z and each one is equal to 60 degrees. Okay, so that is your third parallelogram that they have given. Okay, next we will move on to the fourth one. So here I have to find x, y, z. First, I think y is the the easiest one because it is opposite to 80 degrees. So if this parallelogram is ABCD, B and D are opposite angles, B is given as 80 degrees. Therefore, y is also equal to 80 degrees. Okay, so we got y. Next, let us look at x. I know that A and B are supplementary. So angle A plus angle B is equal to 180 degrees, implies x is equal to 180 minus 80, which is equal to 100 degrees. So I got x, and once I have x, okay, I know that if this is 100 degrees, I know that this is also 100 degrees. Therefore, this has to be 80 degrees because it's a linear pair, and linear pair is sum has to be 180 degrees. Or another way of looking at it is, these two are parallel and you consider BC as transversal, then Z and 80 are corresponding angles, therefore they have to be equal. That means Z is equal to 80 degrees. Okay, these two angles are corresponding angles. Correct? So that's about the fourth bit. Right. Next, fifth parallelogram that they have given. So here I'm going to name it again A, B, C and D. So what do we have opposite to angle D, angle B, which is given as 112 degrees. Therefore, y is equal to angle D is same as angle B because these are opposite angles of a parallelogram, right? And then angle B is equal to 112 degrees. It is given to us. Therefore, y is 112 degrees. Okay. Now, how do you find x and z? One thing you can do is you take the triangle ADC. You already know two angles of this triangle. You can find the third angle by because you know that sum of the angles in a triangle is 180 degrees. Or if you want to stick to the parallelogram, what you can do is, you know that A and D, angle A and angle D are supplementary, and I already know this is 112 and this is 40, so the remaining you can find out from that, right? So if I say angle A and angle D are supplementary because they are adjacent angles of a parallelogram. Okay, so I have y, which I am going to write as 112 because we already found it out, plus 40 plus z is equal to 180 degrees, right? That gives us, So we'll get Z is equal to, this is 152. So 180 minus 152 is 28 degrees, right? So I got the measure of Z as 28. Now can I conclude that X is also 28? What is the reason? Now see, this is a parallelogram. So these two sides are parallel to each other. These two are parallel to each other. So when AB is parallel to DC, okay, consider AC, the transversal AC, okay. If you consider AC as transversal, X and Z are alternate interior angles, okay. So when you have two parallel lines, these two are alternate interior angles, right? So X and Z are alternate interior angles, therefore they are equal in measure, correct? So that is about the measure of X. So let's go to the next question. Can a quadrilateral ABCD be a parallelogram if, so they're saying I have a quadrilateral ABCD, okay, not necessarily a parallelogram. But if it is given that B plus D is 180 degrees, can it be a parallelogram? Now there is no property, or there is no clause in the definition which says that opposite angles can't be supplementary for a parallelogram. So if the opposite angles are supplementary, which is the meaning of D plus B equal to 180, there is no harm in it. So it can be a parallelogram, not must be or should be, but it can be. Okay. For example, what is an example of this? You look at a square, if you look at a rectangle, you know that opposite angles are supplementary, each one equal to 90 degrees. So it is a possibility. So you can say yes, it can be. Next, if AB is equal to DC is equal to 8 centimeters. So let me draw the figure again. Suppose I have a quadrilateral, okay. AB and DC are my opposite sides. AB and DC are opposite sides, they are equal in length, okay. What about AD? AD is given as 4 centimeters and BC is given as 4.4 centimeters. Now one pair is equal in measure, okay, they do not talk about whether they're parallel or not, but the other pair of opposite sides is not of equal measure, and this is not possible in a parallelogram. So no, it cannot be a parallelogram. Next, if A is 70 degrees and angle C is 65 degrees. Let us see. I have ABCD, right? If this is 70 degrees and this is 60, can this be a parallelogram? No, it can't be a parallelogram, because in a parallelogram, opposite angles are of equal measure. So the answer is no. Okay. Next, draw a rough figure of a quadrilateral that is not a parallelogram but has exactly two opposite angles of equal measure. So, did we come across a quadrilateral, okay, till now, where you have one pair, exactly two opposite angles is one pair of opposite angles, one pair is of equal measure. If you can recall, we have looked at kite, right? And in a kite, we know that what is a kite? We looked at a definition that a kite has one diagonal as its line of symmetry, right? And with that, we try to remember all the properties of the kite using that basic definition, right? So this angle is equal to this angle, whereas these two are not equal, right? So it has exactly one pair of opposite angles which are equal in measure. So you can draw the figure of a kite, okay. For this question, draw a rough figure of a kite. What you can do for a kite is, first you draw the diagonals like I have done. First draw one diagonal and then draw a line perpendicular using a set square to that, okay. And make sure that the second diagonal is bisected. The second diagonal, you know, is bisected because this is the line of symmetry. And then simply you can join these end points of these two diagonals. You have your kite. They anyway asked for a rough figure, but still, let's make sure that they understand which quadrilateral we are drawing, right? So this is about the fourth question. Next, I have the measures of two adjacent angles of a parallelogram are in the ratio 3:2. Find the measure of each of the angles of the parallelogram. Okay, so they're talking about a parallelogram. They're saying that it is a parallelogram. So we can use the properties of the parallelogram here. Adjacent angles are in this ratio 3:2. I'll take this as 3x, this as 2x. Okay, if the ratio is 3:2, I can say that each one is 3x and 2x respectively, right? So now what do we know about adjacent angles of a parallelogram? We know that adjacent angles of a parallelogram are supplementary, right? So I'm going to write 3x plus 2x is equal to 180 degrees, implies 5x is equal to 180 degrees. From this I get the value of x. Okay, 180 divided by 5, which is 36 degrees, right? So this is the value of x. From that I'm going to find out the angles. Angle B is equal to 3x, which is equal to 3 into 36, which will give me 108 degrees, and angle C is equal to 2x, which is nothing but 2 into 36, which is 72 degrees. Okay, and then you know the remaining angles. Angle D is opposite to B, therefore it has to be 108, and angle A is opposite to angle C, therefore it has to be 72 degrees, right? So that is your next question. We found out all the 4 angles. Okay, next question. Two adjacent angles of a parallelogram have equal measure. Okay, find the measure of each of the angles of the parallelogram. Now, what do we know about two adjacent angles of a parallelogram? So, okay, let me draw the figure. A, B, C, D. Okay, let me take the adjacent angles A and B. I know that A plus B is equal to 180 degrees because in a parallelogram, adjacent angles are supplementary. Now, in this particular sum, these adjacent angles are equal in measure. Okay, so they're saying that each one is equal to x. Therefore, x plus x is equal to 180, implies 2x is 180, implies x is 90 degrees. Okay, so each of the angles is equal to 90 degrees. So that makes it a rectangle, or it could be a square also, right? Next question. The adjacent figure HOPE is a parallelogram. Find the angle measures of X, Y and Z. Okay, and then state the properties you use to find them, right? So here I have to find X, I have to find Y and Z, right? So here if you see, look at this angle, this is corresponding to angle H of the parallelogram. So if this angle is 70 degrees, why? Because if I take HE and OP as the parallel lines, HE is parallel to OP, and consider HO as the transversal. If you consider HO as your transversal, then these two are corresponding angles. Correct? Now what can we say about corresponding angles? They are equal in measure. Therefore, I can say that 40 plus Z is equal to 70, implies Z is equal to 30 degrees. So I got Z is 30 degrees, right? Now I have Z. That means I have this angle. Okay, I'm going to write it here, 30 degrees. Okay, if this is 30 degrees, what can you say about this angle? This is also 30. In fact, we don't have to look at that time. If this is 40, can I say y is also 40? See, now here I want you to take, please pay attention, HE is parallel to OP and take HP as the transversal. If HP is your transversal, okay, then what does it make 40 and Y? They are the alternate interior angles. So if I look at it, this is how it's going to be. Okay, this is 40 and this is Y. Got it? So these two are alternate interior angles. Therefore, they are equal in measure. Therefore, Y is equal to 40 degrees, right? I have Y is equal to 40 degrees. Next, I'm going to look at X. So now here I have, either you look at the triangle HEP or you simply look at X is opposite to this. So if I know this angle, then I know the measure of X, right? Now these two form a linear pair. These two angles form a linear pair. And this is 70 degrees, therefore this angle HOP, or you can simply say angle O in the parallelogram HOPE, is equal to 110 degrees, because this is 70 and 180 minus 70 is 110. If HOP is 110, then X is also equal to 110. So that is about XYZ in this figure. State the properties you have used to find them. So for finding Z, what did we use? We used the property that the corresponding angles are equal in measure when you have two parallel lines, right? That is the property we used. And to find Y, we used again alternate interior angles are equal in measure. And in order to find X, we use the property opposite angles in a parallelogram are equal in measure, right? So that is about the seventh question. So here I have GUNS is a parallelogram. I have to find X and Y. Now here they have given side lengths. What is the property in a parallelogram regarding the side lengths? Opposite sides are of equal length, right? So GS is equal to UN. That means 3x is equal to 18. That means x is equal to 18 by 3, which is 6. Okay, centimeters. Next, I have 3y GU is equal to SN. That means 3y minus 1 is equal to 26. That implies y is equal to 26 plus 1, 27 by 3, which is 9 centimeters. So I have the values of x and y as 6 centimeters and 9 centimeters. In the next parallelogram that they have given, I have RUNS, right? Now I'm going to name this point of intersection as O. And now the diagonal lengths are given. What is the property? We know that the diagonals in a parallelogram bisect each other, right? So I know that SO is equal to OU because the diagonals in a parallelogram bisect each other. That means y plus 7 is equal to 20, implies y is equal to 13 centimeters. Okay, and then I have RO is equal to ON, implies x plus 13, y is 13, we already found out, is equal to 16, implies x is equal to 3 centimeters, right? So this is about x and y in the next sum. Next, ninth question. They have given us two parallelograms RISK and CLUE. Find the value of x. Now here you need to notice that where does x, this angle x, where is it? This is the angle that belongs to this particular triangle. So let me name this as O. So I'm looking at triangle EOS. Okay. So in order to find this, I need these angles first, the remaining two angles, right? So that is one way of finding x. Now, how do I find out this angle? Now, this angle in parallelogram RISK, okay, angle S is opposite to angle R, and therefore they are equal in measure. Okay. Now, do I know angle R? I know angle R because these two are supplementary and this is 120, that means this is 60 degrees. Okay. So, because angle R plus angle K is equal to 180 degrees and K is 120, therefore R is 60. If R is 60, then S is also 60 degrees. Okay. Now, let's find out E. If you look at parallelogram CLUE, if you look at parallelogram CLUE, L is opposite to E. Angle L is equal to angle E. Why? Because in a parallelogram, opposite angles are equal in measure. Now, L is 70 degrees, that means E is also 70 degrees. So, I have got a triangle EOS, okay, where I know two angles. I can find the third angle, right? So, x plus 70 plus 60 is equal to 180 degrees, implies x is equal to 50 degrees. So, that is your ninth question, okay? Next, they have given a figure and they are saying explain how this figure is a trapezium, okay? It is a quadrilateral because it has four sides, correct? Now, if you look at these two angles, that the measures that they have given, 100 and 180, you know that 100 plus 180 is, 100 plus 80 is 180. That means L and M are supplementary. If L and M are supplementary, that means these two lines are parallel to each other. And if you have a pair of parallel lines in a quadrilateral, then it is a trapezium, right? So therefore, because this is 180 degrees, implies NM is parallel to KL, implies it is a trapezium. Then they're asking which two sides are parallel. KL and MN are parallel. NM and KL are parallel to each other, right? Next. Find measure of angle C in this figure if AB is parallel to DC. Okay, it's not a parallelogram, it is a trapezium. If this is 120 degrees, can you find this angle C? Okay, so you know that angle B plus angle C is equal to 180 degrees. Okay, why? Because when you have a pair of parallel lines, the co-interior angles are supplementary. Therefore, angle C is equal to 180 minus 120, which is equal to 60 degrees. Okay, so that's it. That is your 11th question. Next question. I have given in the given figure P and S. I have to find P and S if SP is parallel to RQ. Okay. If SPS is parallel to RQ, then find P and S. Now this symbol means this is 90 degrees, right? And these two are parallel, these two are co-interior, therefore S is also 90 degrees, right? And then I have to find this. Now angle P, angle S is 90 degrees, okay? I have angle P plus angle Q is 180 degrees. Because these two are parallel and if you take PQ as transversal, these two are co-interior angles and they are supplementary. Therefore, angle P plus angle Q is 180, implies angle P is equal to 180 minus 130, which is 50 degrees. Therefore, I have the angles P and S, right? Now they're saying if you find the measure of angle R, is there more than one method to find angle P? Okay. Now that you have found R, and maybe he meant S. Once you have found R and S, okay, can you find P without using the properties of parallel lines? What you can do is, like we have done earlier, you can use the property that in any quadrilateral, sum of all angles is equal to 360 degrees. Okay. So now I have angle P plus 130 plus 90 plus 90 is equal to 360 degrees. Therefore, angle P is equal to, now this is 130 plus 90, which is 220, plus 90 gives you 310. 360 minus 310 will give you 50. Again, you got the same answer, 50 degrees. So that is another way of finding the fourth angle, right? So with this, we come to the end of the exercise 3.3. Okay. In the next video, we are going to look at further special cases of parallelograms and what are the properties, additional properties that these parallelograms will be having, right?